The question of what existed before the Big Bang has sparked interest and debate for a long time. It is a big mystery, not just about how we might understand the universe but also about the limits of human knowledge. Imagine standing on the edge of everything, thinking about what was there before the universe began. The Big Bang marks the start of everything we know: time, space, and matter. But was there something before it? Could there have been a time before this incredible event? And if so, what was it like? As we investigate, science leads us on a journey into ideas that challenge what we think we know. Famous physicist Brian Cox, known for explaining the universe's wonders, suggests that something amazing might have existed before the Big Bang. He asks us to think differently about reality and existence. In this discussion, we will dissect the science and ideas that might help us understand what came before everything we know. We'll look at theories about quantum changes, dark energy, and even the potential for multiple universes. The answers might surprise you, and they could change the way we understand our place in the universe. Let's investigate a world beyond imagination, where mysteries still puzzle scientists and, at times, leave them questioning everything. Understanding the Big Bang. To understand what existed before the Big Bang, we first need to know what the Big Bang actually was. Scientists say the Big Bang was the moment when the universe became incredibly hot and condensed, rapidly expanding and starting the development of matter and energy. When we look at the stars and galaxies today, we see signs of that hot beginning, as galaxies spread out from a starting point. But why did this happen? And was there anything before this hot start? Inflation and the birth of the universe. As suggested by the cosmic theory of inflation, before the Big Bang, the universe was cold, empty, and void. But this emptiness wasn't completely empty, it had a lot of energy, resulting in the rapid expansion of space itself. This rapid growth, called inflation, happened so fast that it set the stage for everything that came after. This expansion slowed down, and the energy turned into matter and the forces we see as the Big Bang. But how did this energy get there? And why did it suddenly create the universe? Some scientists believe that inflation created patches of the universe, each with its own Big Bang. Picture a fabric stretching endlessly with bubbles forming here and there, each bubble representing a different universe, including our very own. This concept, known as the inflationary multiverse, hints that there could be an infinite number of Big Bangs and universes. Our own universe is just one of many. This mind-blowing idea challenges how we think about the universe and raises the question, what else is out there? The nature of nothingness. The idea of nothingness before the Big Bang is speculative and not based on facts. But even if you removed all energy, particles, and radiation, the universe would still not be completely empty. Space is filled with dark matter, dark energy, and quantum fields, forces and energies that exist even when space seems empty. Even if we imagine stripping away all these forces, space would still have new kinds of energy. This alone is puzzling for scientists because it suggests that true nothingness may be impossible. Space itself has qualities, rules, and constants that keep it from being completely empty. Imagine a region with literally nothing in it, no particles, no energy, and no radiation. Even then, quantum fields and constants would continue to exist. This means even this nothingness has properties. One such property is called zero-point energy, which is the lowest possible energy level of quantum fields. Even at this state, particles can suddenly appear and disappear, creating strange activity even in what should be empty space. This challenges our idea of nothingness and suggests that even before the Big Bang, there might have been something that researchers are still attempting to comprehend. The possibility of an eternal multiverse. One of the most surreal ideas in modern science is the concept that inflation could continue forever. If inflation created our universe, it might still be happening elsewhere. Brian Cox talks about a huge, endless inflationary multiverse, where universes are constantly being created and expanding. Imagine each Big Bang as a spark that starts a new universe, while inflation continues in other areas, creating countless other universes. This process could, in theory, go on forever. This idea of new universes is fascinating, offering the possibility of a fractal universe, where each new universe creates its own Big Bang. Each universe would be separate, not affected by others, because space is expanding so quickly. For scientists, this idea is both exciting and unsettling because it suggests that the universe has no real beginning or end. Imagine our universe as just a tiny part of a much bigger, endless design, always expanding and creating new universes. What if the truth is that there is no end or beginning, but rather an existence of universes in an unending cycle of birth and death? Quantum fields and the origins of the universe. According to quantum field theory, the universe isn't just a collection of space and moving matter, it is a complex network of energy fields that interact to create everything we see. These fields are like invisible oceans, with particles acting like waves or disturbances. Even at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, taking energy and then returning it. This leads to virtual particles, particles that exist only briefly before vanishing, leaving only a faint trace of their existence. The idea of virtual particles challenges our understanding of complete emptiness. Even in a totally empty universe with no matter or energy, would we really have nothing? According to quantum field theory, no, you would still have fields that are always active, sometimes creating particles. This constant activity in what should be empty space shows that the universe doesn't recognize our idea of nothing. These fields and forces continue to function, preventing complete emptiness. This brings up a fascinating question. If fields create particles and particles create matter, could the universe itself have emerged from this nothing awash in quantum fields? The role of dark energy. Dark energy is a mysterious force responsible for the universe's accelerated expansion. But did dark energy exist before the Big Bang? Some scientists think that present-day dark energy may be the leftover energy from before our universe began. The properties of dark energy seem to point to a powerful force that might have existed in some form before the Big Bang. Some theories suggest that dark energy, in a stronger form, might have driven the rapid expansion of the universe in the beginning. The fact that dark energy exists suggests that, even if all matter and radiation were removed, this force would continue to stretch space. This raises a troubling question. If dark energy existed before the Big Bang, could it have caused the conditions that led to the creation of our universe? Cyclic cosmology, an eternal universe. Another theory, cyclic cosmology, offers an alternative perspective on the Big Bang. Instead of seeing it as a one-time event, it suggests that the universe goes through endless cycles of birth, death. What comes next? The question of what existed before the Big Bang remains one of the greatest mysteries in science. Theories like quantum fluctuations, cyclic cosmology, the inflationary multiverse, and dark energy offer potential answers, but none are yet proven. Scientists continue to explore these ideas, using advanced telescopes, gravitational wave detectors, and particle physics experiments to uncover more clues about the origins of our universe. If the universe truly came from nothing, then what does that say about the nature of existence itself? Could the laws of physics, which govern everything we know, have emerged from a deeper, more fundamental reality? Or do they exist eternally, guiding the birth and death of countless universes? New discoveries in cosmology may one day give us definitive answers, or they may only deepen the mystery. But one thing is certain, our quest to understand the origins of the universe is far from over. As we continue to push the boundaries of knowledge, we may find that the universe is even stranger and more fascinating than we ever imagined. Perhaps, in looking back toward the beginning, we will also uncover new insights about the future of the cosmos and our place within it. After all, the search for answers is what drives science forward, and the ultimate question of what came before may be just the beginning of an even greater journey. Existed before everything? The answer may be stranger and more incredible than we ever imagined. As we continue to explore the origins of the universe and the possibilities regarding the previous Big Bang, we dive deeper into the realms of speculative science. While some ideas test the boundaries of our understanding, others offer us a fresh perspective on how the universe might have come into existence. One thing remains clear: the nature of the universe is full of surprises, and the mysteries of its earliest days may be even more complex than we can imagine. One possibility is that the universe could have gone through cycles of expansion and contraction, as suggested by the concept of the Big Crunch. In this theory, the universe might one day come to an end, only to explode in another Big Bang, restarting the cycle. This cyclical model suggests that the universe may not have a true beginning or end but instead continues in a cycle of births, where each new cycle is a new version of the universe. As science progresses, we might find solutions to these profound questions, but for the time being, the mystery of what was before the Big Bang will continue to intrigue and inspire curiosity. As we investigate more deeply what existed before the Big Bang, it's important to acknowledge that much of the research around this idea is still highly speculative. Despite our ability to observe the universe's current structure and study its origins through the Big Bang, what truly happened before this event is still beyond our reach. This does not mean that the search is in vain. Rather, the journey itself may reveal more about the fabric of reality than we could ever have imagined. One of the most profound aspects of cosmology is the role of time itself. As we know, The Big Bang represents the beginning of time and space as we understand them, so the very question of before becomes problematic. According to Einstein's theory of relativity, time and space are not separate entities but part of an interconnected whole. This indicates that asking what happened before the Big Bang may be meaningless, as time itself may not have existed prior to the event. If time is tied to the birth of the universe, there might have been no before to speak of at all. The concept of before the Big Bang poses another paradox. In a universe where the creation of space and time occurred in the same event, how can we apply our conventional understanding of past, present, and future? Could it be that time, whether cyclical or not, is not bound to a linear progression? This leads us to the idea of time as a dimension that could stretch, compress, evolve, and even loop with no predetermined beginning. These kinds of ideas constantly challenge our human intuition and remind us that the universe operates beyond our everyday perceptions. In the search for answers, one theory that has gained traction among physicists is the concept of quantum turbulence as the source of the universe. In quantum mechanics, particles can appear and vanish on their own from what seems like nothing, a process known as quantum fluctuations. Could the entire universe have emerged from such a fluctuation in a quantum field? This would mean that the universe as we know it might have emerged from a nothingness that was not truly nothing at all, but rather a fluctuating quantum field filled with potential energy. This view suggests that even before the Big Bang, there might have been some sort of quantum void, filled with energy but not matter in the form we recognize today. Yet, there are still even more unconventional ideas that stretch our understanding. A single theory argues that the universe could have originated from a big bounce, a cyclical model where each Big Bang is a rebirth following the collapse of a previous universe. This model suggests that the universe goes through an infinite series of contractions and expansions, where the universe continually collapses under gravity and then explodes again, starting a new cycle of growth. In this view, our current universe may have been preceded by another one that collapsed into a singularity, only to produce the universe we observe today. This theory draws upon ideas in string theory and quantum gravity, but it also raises concerns regarding the nature of these cycles and whether they can continue indefinitely. Interestingly, as our observational tools and technology improve, we may one day find indirect evidence that can offer more insight into these speculative ideas. Projects like the James Webb Space Telescope give astronomers unprecedented views of the universe, capturing light from distant galaxies and uncovering clues about the conditions at the beginning of the universe. By studying cosmic phenomena such as the cosmic microwave background radiation, scientists hope to learn more about the moments immediately following the Big Bang. In doing so, they may find evidence that could help us peer further into the origins of the universe and even explore the question of what came before. There is also the tantalizing possibility that advanced physics, still in its infancy, will eventually reveal more extensive layers of understanding. Theoretical physicists are working on theories that aim to unify quantum mechanics and general relativity, which could allow us to understand the conditions before the Big Bang. The theory of quantum gravity, for example, attempts to describe the behavior of space and time at the smallest possible scales, where the effects of both quantum mechanics and gravity are significant. If successful, these efforts might one day offer a complete picture of the universe's origins and allow us to explore its pre-Big Bang state. Some concepts even suggest that our universe might not be the only one, raising the possibility that we are merely one among an infinite number of universes in a larger multiverse. In this view, each universe would have its own set of physical laws, constants, and properties. Our universe, with its particular arrangement of matter and energy, might simply be one of many in an endless, ever-expanding cosmic structure. This idea also leads to the possibility of parallel universes, where events unfold differently from how they do in our own. The concept of the multiverse could change our understanding of the Big Bang, suggesting that our universe is just one of countless others that have emerged through similar or entirely different processes. Despite the immense challenges of answering what existed before the Big Bang, the pursuit of knowledge continues to expand the horizon of human comprehension. As researchers continue to explore quantum mechanics, cosmology, and the fundamental forces of nature, the answers to these questions may eventually emerge. Whether we discover evidence of a pre-Big Bang universe, uncover new insights into the nature of time and space, or stumble upon entirely new concepts that challenge our current understanding, one thing is clear: the mysteries of the universe are vast, and we have only begun to scratch the surface. While the question of what came before the Big Bang may never be completely answered in our lifetime, the pursuit itself highlights humanity's deepest curiosity, the drive to understand where we came from, what the universe is made of, and the forces that govern existence. This search for knowledge might bring about new paradigms in science and philosophy. As we strive to understand not just the origins of the universe but also the fundamental principles that govern reality. As we push the boundaries of scientific inquiry, new ideas continue to emerge that challenge our perception of reality. Some physicists suggest that our universe may be a simulation, a holographic projection from a higher dimensional reality. This holographic principle, proposed by researchers in quantum gravity, suggests that all the information that makes up our universe could be encoded on a distant two-dimensional surface, much like a hologram. If true, this would imply that the universe as we experience it is simply a projection of deeper fundamental laws, ones that may exist beyond space and time as we currently understand them. Another radical theory proposes that the Big Bang was not the beginning but rather a transition between different states of existence. The ekpyrotic universe theory, derived from string theory, posits that our universe was created through the collision of higher dimensional brands in a larger multidimensional space. This theory suggests that what we perceive as the Big Bang was not an absolute beginning but a violent interaction between cosmic structures, creating the conditions for the formation of space, time, and matter as we experience them. Yet another possibility lies within the many-worlds interpretation of quantum mechanics. In this view, our universe is just one of countless parallel realities that are continuously branching off due to quantum events. If this interpretation extends to the Big Bang, then perhaps our universe was simply one outcome of an infinitely branching multiversal landscape, with other versions of reality preceding and succeeding our own in ways we cannot yet comprehend. The limits of human understanding. While scientific exploration of the cosmos has yielded extraordinary insights, there may be fundamental limits to what we can truly know about the origins of existence. Some philosophers argue that the nature of time, space, and causality may be concepts that only apply within our universe, making it impossible to meaningfully discuss before the Big Bang. Furthermore, the nature of consciousness itself may play a role in shaping how we perceive the universe. Could our very ability to ask these questions be constrained by the limitations of human cognition? Some interpretations of quantum mechanics suggest that observation itself plays a fundamental role in shaping physical reality, raising profound questions about whether the universe even exists in a definable way outside of our measurement and perception. The future of cosmological discovery. Despite these challenges, scientific advancements continue to push the frontiers of knowledge. The next generation of telescopes and space observatories, such as the James Webb Space Telescope and planned successors like the Einstein Telescope and Louvre, promise to uncover even deeper insights into the earliest moments of the universe. Additionally, advances in quantum computing and theoretical physics may one day allow us to simulate pre-Big Bang conditions, testing hypotheses that were once purely speculative. Efforts to unify quantum mechanics and general relativity through string theory, loop quantum gravity, and other cutting-edge approaches could provide the framework needed to answer what existed before the Big Bang with greater clarity. Conclusion: a journey without end. While we may never have a definitive answer to what preceded the Big Bang, the search itself continues to drive human curiosity and innovation. Whether through breakthroughs in physics, new philosophical perspectives, or technological advancements that allow us to probe deeper into the fabric of reality, our quest for understanding will undoubtedly reveal new and unexpected truths about the nature of existence. Perhaps the most profound realization is that the universe, whether eternal, cyclical, or emergent from deeper laws, will always remain a source of wonder. As we explore these mysteries, we are not just uncovering the secrets of the cosmos, but also deepening our understanding of ourselves and our place in this vast and ever-expanding reality.